In this video, we're going to use Desmos to fit a regression to some data. So the data that we have is already in a Google Sheet for us, and it compares forearm length to foot length. So what I'm going to do is I'm going to grab this data, I'm going to copy it, and I'm going to paste it into a Desmos cell. And you can see as soon as I do that, Desmos puts all of my data into a table, and it fits a nice window to my data points. If we look at these data points, and I'm going to make this a little bit darker so we can see it better, projector mode, those data points seem to have a positive linear correlation. So what I'm going to do is I'm going to fit a linear model to these data points, and you can do that either at the top, if you hit enter, or at the bottom of your table. If you want to drag this to the top, you can do that. And we're going to put in a linear regression. Remember, linear regressions look like y equals mx plus b. But if you want Desmos to do a regression on the data points, you have to reference your x1 data points and your y1 data points. So we need to put a 1 next to the y. It will automatically make it a subscript. Same with the x, we need to put a 1 next to it. And then we need to turn this equals into a tilde, which is to the left of the 1. Now what you've told Desmos is you want to regress y against your x values from your table. Now you can see what we have is we have a linear model that's created by Desmos using the data points, and you can see that our R value is somewhat close to 1, so it's a pretty good regression model. The closer that R value is to positive 1 or negative 1, the better your model is. So if we want to actually take those values, here's what I like to tell my students to do. Let's go ahead and nail that line down. So we're going to type in y equals, and if you see right here the m value, I'm going to round to 3 places. So I'm going to put 0.792 x. So I replaced the m with the m the computer told me, and then I'm going to put plus, and again I'm going to round to 3 decimal places for my b or my y-intercept, so that's going to be 4.955. 4.955. And you can see that red line that we made is the same as the regression model. It's rounded, so it's an approximation, but it's pretty close. The other thing that we can do, so I'm going to turn the regression off. In fact, you can get rid of that if you want. We can now use the model that you've put in there. We can use function notation, f of x, so that now we can get inputs and outputs. So because I've turned this into a function rather than just a y equals, I can tell the computer to put in different values for x. So now if I want to know what the, let's see, what were we comparing here? If I want to know the foot length for a specific forearm length, I can put in those values and it will give me an approximation or an estimation. So now I can say, okay, well, what is f of 19 going to be? F of 19 should give us a forearm length of a foot length of approximately 20. Or if I want to say, okay, I have a forearm length of approximately 25. That means my foot length should be at approximately 24.755. And if you look down here in our table, if I had a foot length of 25, a forearm length of 25, I got a foot length of approximately 25. So what this is doing is it's plugging in x values and it's getting out y values, and these would be the values on the line. So if I want to see exactly that point, I can say, okay, I put in the value 25 and I got out f of 25, and you can see that point appeared right here on my line, which is pretty close to the one that's near it. All right, so this is one way that you can actually go through Desmos, do a linear regression, and then use it to get approximations. I hope this was helpful. You can use this now to find the answer to the question that you needed to figure out.